Assalamualaikum and good day, Doctor. My name is Farhanis and I'm from Group 6. My team member is Instan Faharna, Izzat Naim and Muhammad Syafiq Syami. So, my group will present a team assignment 3 which is activity 2. So, the instruction given by lecturer to see section 4.3 page 98 in the textbook and read the case study, and then discuss in your team by using WhatsApp and other platform, and use the iCast software to try generate the result as obtained in the case study, and then record a video explanation of how you use the software to solve the problem design to solve the product design problem, and upload the video in YouTube. So each team only need to work on one case study only. So for the team 6, we should do case study about solvent substitution. So I will pass to the next presenter, which is Intan Farhana will explain further the iCast software.
Bismillahirrahmanirrahim and Assalamualaikum. So first of all, I will begin the presentation for case study of solvent substitution by our group 6, which begin with the generation of candidate through CAPAC database search. So first of all, we will conduct the CAPAC database search. So how do we do it? Is first we click on the CAPAC manager, and this screen will pop out, and then in order to search the result that will came out as shown in figure 4.14 from the textbook page 104, we first click on basic search, and the solvent that we want to substitute is phenol. So we type phenol and search CAPAC TV. So there is a total of 266 result came out, but we need phenol. So here is phenol. So we click on the phenol and view the compound. There, a result will shows as the one shows in figure 4.14, where the pure component data of phenol obtained by basic search in CAPAC database. We can see that all the properties listed here is the same as the one that shown in figure 4.14. Next, we also need to produce results from solvent search. So how we do that is, these are some other properties that are listed for phenols. Okay, so we proceed with result from solvent search, which is shown in figure 4.15. So how do we produce the advanced search? Is we click on advanced search, and in the textbook in page 103, and as my team member Farah has mentioned before, there is two properties that are given by the case study. So we need to key in the properties. First, we will key in. It is given that having melting points below 250 K. So click on the first properties and we search the melting point temperature. Okay, and then it is less than, which is below 250 K. And then the second properties is the Hildebrand solubility parameter. So for solubility parameter, we search the and then it is between 22 to 26. Okay, after we have listed the two properties that are required for this compound the solvent search. So we search CAPAC DB. Okay, and here there is a list of compounds that are recorded, and we can see that there is a total of 41 compounds listed, which is the same as the one that's shown in figure 4.15 for solvent search. That's all from me. proceed the presentation for program B by my other team members.
Assalamualaikum and hi. My name is Muhammad Shafiq Shahmi and I will continue for the generations of new candidate molecules and testing all candidates using ProChem. So firstly, we will click the ProChem. Okay, so for the problem title, we will follow the title from example from the books. So for, the title is Solvent Substitutions, Solvent for Phenol, SLE. So for the generation, acyclic compound and also generation of isomers. Okay, for the pre-selection, we will choose to generate alcohol, ketones, aldehydes, and also ethers. Okay, now we will move on to the non-temperature dependent properties. So for the properties, we will choose the normal boiling point, normal melting point, total solubility parameter, and also log P. Okay, now we will insert the value for all the properties. Okay, for the normal boiling point, we will the important part is for the normal boiling point is the minimum. So we choose the minimum and uncheck the maximum and goal. Okay, for the normal melting point, the maximum is 314 Kelvin. So we uncheck the minimum and the goal. Okay, for the total solubility parameter from the case studies, the range is 22 until 26 megapascal power of half. So because of we have range for the total solubility parameter, so so the goal is not needed. So we will uncheck the goal. We will just use the range. So for the log P, we uncheck all the properties. Okay, log P, octanol over water partition coefficient. It is calculated, but the value is not used for checking the feasibility of the molecule. So we can uncheck the log P. Okay, so now we move on to the mixture properties. We click at the perform mixture calculations and we will see the model. We have 4 models here. Unipa, Unipal, Unilin, and also Unimode. So we will click at the Unimode. We choose Unimode because it works well for both VLE and LLE calculations. So we need LLE calculations, and the condition temperature is 298 Kelvin and with 1 bar pressure. So for the key component, we will search for phenol. So we will select from the database, we search the name, phenol, click here, add. Okay, now we got phenol as our key components. So for the mole fraction, because we have just phenol, one only, so the mole fraction is 1. The solute is phenol. For constraint, we will select solvent power and insert the minimum value. For the max and goal, we will uncheck them. Okay, next we move on to the azeotrope or miscibility calculations. So we will perform the azeotrope calculation and click at the perform SLE calculations. So no azeotrope here. And for the SLE specifications, the temperature is 298 Kelvin. And we click at the solid phase must exist. Okay, now we're done for the value that we need to insert, and we will run the program. Okay, now this is the summary of the result that we get. So from the case study, for our result, it is quite different from the books, from the example from the books. We get the number of compound design is 1,424, and the compound being selected is 521. Okay, for the number of isomers design, we get 6,374, while for the isomers that been selected is 2,863. Okay, this is the compound. You can see we have 2,863 compound here with different isomers. And from the books, the example for the compound is okay, in this one. So this is basically same. We have the example for the properties. So this is another compound that we get from the results. Okay, so I think that's all from group 6 for the case studies of solvent substitutions. That's all from us. Thank you so much.